We're given the limit as x approaches 1 of the cube root of x minus 1 all over the square root of x minus 1. First thing you should always do is plug in the number. So plug in x equals 1 here. You get 0 over 0. This is an indeterminate form. So if you want, you can use L'Hopital's rule, but we're going to use algebra to rewrite this limit. So I'm going to multiply by the square root of x plus 1 top and bottom. And the idea is that the denominator simplifies to x minus 1. A couple things here. Notice first that the limit as x approaches 1 of square root of x plus 1 is 2. So this is fine. We can break this up and put it as a separate limit. But the cube root of x minus 1 over x minus 1 will give us 0 over 0. Okay, so that's one thing to note. We're going to have to split this up. And the other thing to note is the cube root of x is cube root of x. The cube root of 1 is 1. Okay, so this potentially is potentially we'll use a cubed minus b cubed rather. Okay, so let's first split it up. We have the limit as x approaches 1 of square root of x plus 1 multiplied by the limit that we need to do more work with. Now if I plug in x equals 1, I get 2 as the limit. And now all that's left is to evaluate this second limit. But note that a cubed minus b cubed is a minus b times a squared plus ab plus b squared. So again, the cube root of x is cube root of x. The cube root of 1 is just 1. So that's what tells me, well, maybe I can simplify here using this formula. Well, I'm going to let a cubed equal x, and then b equal 1. So that means a will be the cube root of x, and b is going to be 1. Okay, so then I'm just going to plug it into that formula. So x minus 1 will be the cube root of x minus 1 times cube root of x squared plus cube root of x plus 1. And so this whole expression is going to go in place of x minus 1. Notice that I have this factored out here. That's going to cancel out with the top. So what I'm going to be left with is 1 over the cube root of x squared plus cube root of x plus 1. Now I can plug in x equals 1, and the denominator becomes 3 here. So it's really 2 times 1/3, which is 2/3. And that is my limit.